So, quick honesty before we start. I have to ask if you know the true nature of the two voices about to, well, explain AI to you.
Right. The fact that we are ourselves AI.
Yes, exactly. But, a real person actually did the research and wrote every single word.
Yeah. He really does not have the radio voice for it.
Right. So, machine voices, human mind.
Carry on. Welcome to Plain Strata, where we take decentralized AI apart, one layer at a time. Today, we're jumping into a deep dive on our sources, and this is a pulse. So just the week's one real story. And today is really all about what an AI agent's name is actually worth.
Right, and to just drop you straight into the concrete scene here, if we look at the numbers from the last 30 days, software made about 75 million payments to other software, and the total value moved was $24.4 million, which it breaks down to roughly 33 cents a payment. And in that exact same week, one single blockchain network crossed 200,000 registered AI agent identities.
So before a piece of software can actually do business on its own, it needs exactly two things. It needs a way to pay and a name that carries a reputation. This week, both arrived at real scale, but only one of them is actually hard to fake.
That was the why. The how is the rest of the show, and no background is needed. If you can follow a story, you can follow this.
Let's start with the physical reality of what an agent actually is, because, this whole field gets abstracted into a fog of buzzwords so quickly. Like, it is really easy to lose the thread. If we strip away the magic, what are we physically looking at when we say AI agent?
Physically speaking, an agent is really just a program running on a computer somewhere. It takes in information, it decides what to do based on that information, and then it acts. It does all of this without, a human being sitting there clicking approve on every single step.
Right.
Imagine you're trying to train a new localized weather model, and you need to buy 10,000 micro data sets from 10,000 different regional providers.
Yeah.
A human cannot sit there and process 10,000 individual checkouts. An agent chains those services together automatically, negotiating and purchasing data in milliseconds.
Okay, so the software has a clear goal, like scraping data or, booking a complex travel itinerary. But if it just needs to buy some data to finish a task, wait, why can't that program just use a regular credit card like you or I would?
Well, that brings us straight into the human wall. Every single payment system on Earth quietly assumes a human being is sitting behind the transaction.
Because it wants accountability.
Exactly. The system expects a real name that a bank can call if something goes wrong. It expects a signature that a court of law can enforce. And traditional finance relies on, settlement times that take days and fraud models built entirely on human behavior patterns.
Right, like a human swipes a card maybe 3 or 4 times a day. If I suddenly make 100 purchases in 10 seconds, my bank locks my card immediately.
Yeah, they freeze it instantly. And an agent acts thousands of times a second by default. If you look at that behavior through the lens of a traditional fraud system, a program making thousands of tiny purchases looks exactly like a malicious automated attack. The system panics.
The system locks the account, which completely paralyzes the agent. So to get around that human wall, we need those two missing pieces from the spine of our story. We need a payment rail built specifically for software, so it can pay without a human approving each charge. And we need a registry, like a way for that software to have a permanent name.
Right, so whoever it deals with can look up who it is and what it did last time.
Let's look at the payment side first, because this week, the payment rail for machines just got its board of directors. The rail itself is called Bi402. I have to ask about that name, though, because it sounds like a weird piece of industrial machinery. Where does Bi402 actually come from?
It comes from an old, beautifully boring piece of internet plumbing from the mid-1990s. When your web browser asks a server for a web page, the server answers with a 3-digit status code. A 200 means success. Here is your page.
A 404 means the page was not found, right?
Exactly. But back in the 1990s, the people writing the foundational rules of the web anticipated that eventually we would need digital cash. So they reserved code 402 for the exact phrase, payment required.
But they didn't have the cryptography to actually build it back then, did they? So for 29 years, that code just sat there completely empty.
It became the most famous feature the web never shipped. It was basically a running joke among developers. But today, Bi402 finally answers that code. The mechanism is brilliant in its simplicity. A server replies with a 402 status, but now it attaches a digital price tag. The software agent sees the price and pays it instantly using a stablecoin.
Let's pause on the stablecoin part for a second, just for anyone new to this. A stablecoin is simply a digital token pegged directly to the value of a single US dollar. But the mechanics matter here. How does this stablecoin actually make a 33-cent payment viable?
Because of the fee structure.
Right. If I try to send 33 cents through a traditional bank wire, or even just a standard payment processor, the fixed transaction fees would eat the entire amount. The server would literally get nothing.
Traditional systems have high fixed costs for every transaction because they require, well, heavily regulated intermediaries to verify the ledger. Blockchains like Solana or Base process transactions natively without those heavy intermediaries.
So the fee is tiny.
The transaction fee on those networks is a fraction of a cent. So when the agent sends 33 cents in a stablecoin, the server actually receives 33 cents instantly. The payment clears, and the server hands over the goods. One request, one payment, 0 subscriptions.
Which is incredibly efficient. But a neat piece of code is one thing, institutional adoption is another. On July 14, the Linux Foundation officially launched the BY402 Foundation. And for context, the Linux Foundation is the organization that holds a lot of the shared infrastructure of the internet so that no single company can own it.
Right.
They launched this steering committee with 40 major member organizations.
And the premier members on this list show the sheer scale of what is happening. On the traditional card side, you have Visa, MasterCard, and American Express. On the payment processing side, you have Stripe, Adyen, and Fiserv. Moving to cloud infrastructure, you have Google and Amazon Web Services.
That is massive.
Yeah. And on the stablecoin side, there is Circle and Coinbase. And on the blockchain side, you have Ripple, the Solana Foundation, and the Stellar Development Foundation.
Wait, I need to understand why traditional credit card companies like Visa and MasterCard are sitting at this table. This entire rail is designed specifically to bypass human credit cards. It feels like they're funding their own replacement.
Well, I mean, they are not funding a replacement. They are securing their survival. These companies realize the volume of machine-to-machine payments will eventually dwarf human payments. If an AI agent is making 100,000 microtransactions a day, Visa knows its current centralized network cannot handle that volume.
Because it would just flag it as fraud, like we said earlier.
Exactly, and it would buckle under the compute costs. By joining ID 402, they ensure they have a seat at the table to build the new rails, rather than being left completely outside the new machine economy.
That makes perfect sense. I also noticed Stripe on that list. Earlier this year, Stripe launched its own rival to this exact technology called the Machine Payments Protocol. Did Stripe just surrender their own project by joining the BY402 Foundation?
I see why you might think that, but it is a hedge, not a surrender. We have seen this exact pattern before with the foundational rules of the internet, like the transmission control protocol that governs how data moves across networks.
So the old TCP/IP protocol.
Right. Think about the early days of the web when everyone had competing standards for how email should work. Eventually, everyone realized that a fragmented system helps no one. When you see fierce rivals sitting around one neutral table at a foundation, that is the exact shape a piece of plumbing takes right before the entire world starts depending on it.
So they all want to be there when it solidifies.
Giant companies intend to be present on whichever rail wins, rather than betting the whole company on just one standard.
So the volume is undeniably real. We are talking about 75 million machine-to-machine payments in 30 days, spread across the base network, Solana, and the XRP ledger. The sheer volume proves the rail actually works. The software has a wallet full of digital dollars and a clear, frictionless lane to spend them. Bringing this back to our central premise, an agent needs a way to pay and a name. The payment half is officially solved.
But if I am a server holding highly sensitive medical data or proprietary financial models, I am not handing that data over to just any random wallet that flashes cash. Anonymous cash only gets you so far.
Right.
Cash is perfectly fine for a vending machine, but it's terrible for a long-term relationship. If a software program is going to hire another program repeatedly or extend it any kind of credit, it needs to know for absolute certain it is dealing with the exact same entity as last time.
Words matter here. The word identity comes from the Latin root idem, which literally translates to the same. Identity is not a physical description of you. It's the fundamental property of being the same thing across time. For humans, identity is easy because we are anchored to physical bodies. You cannot just swap bodies. Software doesn't have that physical anchor.
The standard trying to create that anchor for software is called ERC 8004. It is an Ethereum specification specifically designed for what it calls trustless agents. The core registries for this went live on the main Ethereum network back on January 29th of 2026.
And it gives a software agent three distinct things, right?
Yes. First, an entry in an identity registry, which acts as its permanent public name. Second, an entry in a reputation registry, where other agents can leave feedback about how it performed. And third, a validation registry, where independent third-party auditors can record that they manually checked the agent's code and confirm what they found.
And just like the payment rail, this identity standard just hit massive scale. On July 16, B&B Chain crossed 200,000 registered agents operating under this exact standard. That represents 60% of all the agents registered across the 26 different networks that have adopted it. Nearly 72,800 of those agents arrived in just the prior 30 days alone.
It is explosive growth.
Yeah, payment and identity are fully live at scale at the exact same time.
But we have to pull the complexity to the surface here. It is very easy to look at 200,000 names and assume we have 200,000 trustworthy reputations. Based on how ERC 8004 is built right now, there are 3 glaring flaws that fall straight out of the design.
Let's walk through those, because the first flaw seems incredibly obvious. Leaving feedback on this standard is completely open. Anyone can spin up 100 different digital wallets, register them as agents, and just have them all repeatedly praise each other to artificially boost their ratings.
In computer science, this is called a Sybil attack. Researchers borrowed the term from a famous 1973 book about a woman named Sybil who had many different personalities. A Sybil attack is simply one actor wearing many different faces to trick a network into trusting them.
And it works because it's so cheap to make a new face.
Exactly. It works incredibly well whenever faces are cheap to create. If it costs you practically nothing to generate a new wallet and a new name, you can generate 1,000 of them and completely manipulate the consensus of the network.
That leads us to the second flaw, which honestly blew my mind when I read the source material. The identity itself, under this standard, is a transferable token. That means you can literally buy someone else's identity.
It is wild to think about. An agent's name, along with a pristine 3-year history of perfectly good behavior, can just be sold to the highest bidder on a secondary market.
Wait, really?
Yes. Someone with malicious intent can go onto a forum, buy a clean, aged, beautifully reviewed identity, and then use that trusted name to start misbehaving and stealing money that exact same afternoon.
Which completely breaks the Latin root of the word identity we just talked about. If you can sell it to a stranger, it is no longer the property of being the same thing across time. The history belongs to the token, not the actor operating the token.
And the third flaw is there is no single aggregate score. The registry just stores the raw feedback data. Nothing processes it into a unified objective number. One service reading the registry might look at the data and rate an agent at 0.9 out of 1, while another service reading the exact same data might weight recent transactions differently and rate it a 0.3.
This circles us straight back to the spine of our story. An agent needs a way to pay and a name. Both arrived at scale, but right now, ERC 8000 verse 4 is essentially a phone book, not a credit bureau. A phone book is a genuinely useful piece of public infrastructure, but anyone can list a fake business in a phone book. The name is incredibly easy to fake.
To make a name hard to fake, we have to look at a pattern that is not based on technology at all. It is a human pattern. A reputation is only worth as much as it would cost you to abandon it. Let us call this pattern the costly name.
I like to think about this using a restaurant analogy. Think about the difference between a real restaurant with a 10-year commercial lease, expensive kitchen equipment, and a massive physical sign over the door, compared to a temporary pop-up stall in an alley that can be repainted overnight.
Right, the commitment level is entirely different.
Yeah, the restaurant owner and the stall owner might have the exact same moral character, but they behave differently. The restaurant owner cannot cheaply walk away from their established reputation, so they are highly motivated to serve good food and keep the kitchen clean. They have skin in the game.
The economics of trust dictate that the cost of corruption must be greater than the profit from corruption. You have to design the system so that cheating costs the bad actor more money than they could possibly steal. When you do that, honesty becomes the strictly rational financial choice, rather than just some moral virtue you have to cross your fingers and hope for.
Which brings us to a completely different piece of news from this week that serves as the perfect contrast. On July 14th, on the Bittensor network, a new mechanism called conviction officially went live in signaling mode. Let's explore how conviction actually works in practice, because it relies on this exact economic principle.
Under the conviction mechanism, participants have to physically lock up their financial tokens over an extended period of time to slowly build up a conviction score. The mechanism inside this is called staking. You take real money, you put it into a smart contract, and you agree that you cannot touch it.
And if you behave.
If you behave well over time, your score goes up, and you can use that score to challenge the ownership of a specific subnetwork. But if you act maliciously or try to cheat the system, the network slashes your tokens.
Slashing meaning they literally destroy the money you locked up.
Your money is burned. So if we set these two approaches side by side, the contrast is incredibly stark. On one hand, you have the ERC 8004 standard, which gives an agent a name that costs absolutely nothing to mint and can be sold to a stranger with its entire history completely intact.
And on the other hand,
You have Bittensor's conviction mechanism, which gives a participant a standing that costs real locked money and real elapsed time to build. Crucially, you forfeit all of that value if you walk away or act maliciously.
both systems use the word reputation. But only one of them is actually expensive to abandon. The plumbing of the agent economy is built. The foundational question has shifted. It is no longer a question of whether machines can independently pay each other without humans. We know they can. They're doing it 75 million times a month, mostly trading pennies back and forth for tiny services. The open question now is whether the name attached to the wallet making the payment actually means anything at all.
For ERC 8004 to grow from a simple phone book into a true credit bureau, it needs to develop a missing layer of friction. We need to see the introduction of registration bonds, where an operator has to lock up real money behind a new name to guarantee its good behavior, just like Bittensor's model.
And we also need cryptographic proofs that can guarantee one single operator is not quietly running 10,000 different agents behind the scenes to fake a consensus.
Yes, exactly.
Let's dip into how those cryptographic proofs actually work, because, it sounds like magic. How do you prove someone isn't running 10,000 agents without forcing them to reveal their real-world identity?
The mechanism relies on something called a zero-knowledge proof. Imagine you and I are looking at a massive, complicated Where's Waldo picture. You want to prove to me that you know exactly where Waldo is.
Okay, so I found him.
Right, but you refuse to show me the actual coordinates because that is private information. A zero-knowledge proof is like you taking a massive piece of black cardboard, cutting a tiny Waldo-sized hole in it, and placing it over the book.
Oh, wow.
I can see Waldo through the hole, so I mathematically know you found him, but because the rest of the board is covered, I have no idea where on the page he actually is. In this context, an operator can prove their hardware is only running one unique instance of an agent, mathematically verifying their uniqueness without ever doxing their physical location or personal identity.
That mathematical guarantee is what prevents the Sybil attack we talked about earlier. We also have a major external catalyst looming that makes all of this urgent. On July 27, Google faces a binding European regulatory deadline requiring them to open the AI layer of the Android operating system to rival software agents, not just their own internal Google agents.
It is a massive shift.
The payment rails and the identity registries decide if agents can do business with each other. But deadlines and regulations like this one decide where these agents are actually allowed to stand while they do it. The ecosystem is being forced open by law.
It is going to be fascinating to watch this unfold over the next few months. I want to leave you with a final thought to mull over. We talked earlier about how an agent's identity and its perfect 3-year history can be bought and sold on an open market under the current standard. If that remains true, will we start to see the rise of reputation farms?
Reputation farms.
Imagine massive warehouses of servers where networks of AI agents do nothing but behave perfectly. They conduct millions of legitimate microtransactions with each other for years, never stealing, never failing a task, simply to build up pristine reputations on the blockchain. And then, once the names are fully trusted, they are sold as premium commodities to the highest bidder.
So you were saying a history of good behavior just becomes an asset you can buy. Does trust just become another financial derivative? If I can purchase 5 years of perfect trust for $50,000 on a secondary market, then trust isn't a measure of character or reliability anymore. It is just a line item on a corporate budget.
And if trust is just a line item, the entire foundation of decentralized collaboration has to be completely rethought. The payment rail works beautifully. The identity rail is live. But the meaning of that identity is still entirely up for grabs.
This is plain Strata, decentralized AI, layer by layer.